All right, these are some notes for section 6.6 on types of functions. Now, I will warn you, this is not all of your notes, but you do need to understand these different types of functions, and we're going to look at 3 in this video. Okay, the 3 types of functions we're going to look at are linear, quadratic, and exponential. And as we go through, I want you to fill in this chart. And some of this stuff you may already know, but I want you to fill it in anyway, because these types of things are very common when you take the EOC, or sometimes when you take the ACT, these things show up. So you need to know what they are, and you need to be able to answer questions about them. First thing we're going to do is we're going to fill in this linear column. We're going to start with linear. Okay? Some examples for linear. This is the general form for linear. Y equals mx plus b. And you should know that as slope-intercept form. Okay? That's the general form for linear. So if you see a function that is in that form, that's a linear function. And here are some examples. Y equals 3x plus 2. Y equals 2x minus 3. Y equals negative 1/2 x minus 7. All of those are in slope-intercept form. Now some of them may be reversed a little bit, like this last one. We could make that 7 plus y equals negative 1/2 x by adding the 7 to the other side. But we could still put it in linear form, or slope-intercept form, which would make it linear. Okay? Now some quick hints, some things to look for, if they give you an example like that, is an exponent of 1 on x. Okay, well, x should have an exponent of 1, which usually means it's not going to be written. Okay, the exponent. There should be an x in the problem, but the exponent won't be written in the problem. If we look at these examples I gave you up top, I didn't put an exponent of 1 on any of the x's, but it's understood that it's there. Okay, and that's one of your hints. That's what makes one easy way to tell if a function is linear, if it has an exponent of 1 on the x. Now, the graph, the description for these is that they make a line. Okay, pretty simple. Linear, line, makes a line. And there are 4 types of lines we could have. You could have a positive slope, negative slope, zero slope, or no slope. And remember, those are vertical and horizontal lines. Okay, so those are the 4 types of lines you could have. I will warn you, though, and this is something that we haven't really talked about in this class. You may have talked about it in Algebra 1, but you will get to it in Algebra 2, is that vertical lines are not functions. Okay, so if you see a vertical line, it's not included in this. It's not a function. Only horizontal, positive, and negative slopes, or lines, those will be functions. So our graph, we could really have 3 different graphs. The general one I'm going to draw on here is one with a positive slope. Remember, it's positive because you're going up to the right. If it was going down to the right, it'd be negative, and then we all should know horizontal line goes left to right. But again, vertical lines are not functions. They're still linear because they make a line, but they're not a function. So don't include that. Now, if you see a chart, I've given you an example here. We're going to fill in our chart. There's a pattern you see in the chart, and this is important to see. Okay? Let's fill in our chart. We've got y equals 3x plus 2. We're going to plug in these 5 numbers here, negative 1 through 3, and we're going to see if there's a pattern between the values we get for y. So let's plug in negative 1. 3 times negative 1, that's negative 3, plus 2 would be negative 1. And then we have 0. 3 times 0 is 0, plus 2 is 2. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. Now there is a pattern in this y column here, and this is something you could look for if they give you a chart like this and ask you if it's linear or not. The pattern is that it increases, could decrease, by same number each time. Here, to get from negative 1 to 2, we add 3. To get to 2 to 5, we add 3. So we're adding 3 each time. And that's one way we could tell it's linear. We add a constant number each time. And that number may be different depending on the problem. It may not be 3 every time. We could add 1, we could add 0.5, we could add 77. It doesn't really matter as long as we are adding the same number each time. That's a clue that it's linear in the chart. Okay, so there's our linear column. Next column is quadratic. Now, this isn't quite standard form for a quadratic, but we're going to use this because it will get the point across. Y equals ax squared plus b. Okay, that's what we're going to use. Really, there are 3 terms in a quadratic, but we're only going to use 2 because you'll get the point across. You'll be able to see what's going on. And that's the form we're going to use for a quadratic. Here are some examples. Y equals, say, x squared plus 3. Y equals 2x squared. Y equals 7x squared plus 2x minus 1. Those are all examples of a quadratic function. Now, there is something in common of all of them, and it's not the number of terms, because if you look, the first example I gave you has 2 terms, the second one has 1, and the last one has 3. So it's not the number of terms, but there is something that's common. And this is what you could look for if I just give you an example of a problem like that and ask you if it's quadratic or not. It is that the exponent is 2 on x. Okay, and that's the difference between a linear and a quadratic. Linears only have an exponent of 1. Quadratics will have an exponent of 2 on the x, and it has to be written. Okay, anything other than 1 for an exponent we have to write. So that 2 should be written in your problem somewhere, but it has to be the exponent on the x. It can't be on anything else. Now your graph description, it's going to make what's called a parabola. Okay, which is just a U shape. And it's symmetrical on both sides, left and right. Okay, you should be able to fold that in half, and the left side should be exactly the same as the right. Now, it could open up, it could open down, but what your graph would look like is something like this. That's a parabola opening up. I'm going to put another one down here. You could have a parabola opening down. But it's a U shape. That's all it is. Okay, and that's something you should be able to recognize. You should know that. I think you learned that in Algebra 1, so you should have seen it before. If you haven't, though, make sure you know that it's called a parabola, and that parabolas go with quadratics. Now, I've got an example down here for your chart. We're going to do the same thing we did for the linear one. We're going to fill it in. And we've got y equals x squared plus 5. We're going to fill in for the same 5 numbers, negative 1 through 3. When we plug negative 1 in, negative 1 squared, remember if we square a negative, it's positive. So that becomes positive 1 plus 5, which is 6. 0 squared is 0, and 0 plus 5 is 5. 1 squared is 1, plus 5 would be 6. 2 squared is 4, plus 5 is 9. And then 3 squared is 9, plus 5 would be 14. Now there's 2 things that you can notice in a chart for quadratics. And now I want you to realize they may skip some numbers. They may not do consecutive numbers like we've done here, negative 1 through 3, using every number through there. They may just pick out random numbers, and you may have to fill in the chart for the missing stuff in order to see the pattern, which is something they do a lot on standardized tests. So make sure you realize that. They may not go in consecutive order. They may go negative 1, skip to 2, do 3, skip to 9, just skip some, leave some blanks in there for you to fill in. So watch for that. Because then these chart and patterns things that we're talking about won't always work, because it's not consecutive. But here, notice that you have 6 twice. Okay? There may be repeats in the y column. And that's because if you look up here in our graph, it's the same on the left as it is on the right. So in our chart, there should be a point for our y values where they're the same going up as they are going down. There should be repeats. Okay, that's where the connection is, and you'll talk more about that in Algebra 2. But that's something you can look for. You can look for repeats in your y column. Okay, the top should be the same as the bottom at some point. Now the second thing you look for is that you're adding odds each time. Now it's not the same odd, and that's what confuses people every once in a while, because if it were the same odd, it would be linear over here. Like we added 3 every time, that's linear. But in our quadratic example, to get from 6 to 5, well, the difference between those is 1. Okay, so here it's 1. 5 to 6, it's 1 again. 6 to 9, though, the difference is 3. 14 to 9, the difference is 5. So we're adding a different odd every time. And they should repeat, just like the repeats in the y column. At some point, you'll see some of the same numbers being added, but they should continue to increase or decrease. Okay? I shouldn't go 1, 3, 5, 1, 3, 5. That shouldn't be what I'm adding every time, because that's not going to be a quadratic. It has to keep increasing. So if I start with 1, I should go 1, 3, 5, 7, 9, 11, and keep going. It shouldn't go back down. But if it does, it should continue to keep going that way, because remember, there's some point where it's got to switch. Last column here is exponential. General form for an exponential function is y equals b to the x power. Here are some examples. Y equals 2x, y equals 3x, y equals 1/2 x. All of those are exponential functions. Okay? The common thing to look for here is that the x is the exponent. Okay? Or part of the exponent. You may have 2x plus 1 as your exponent, but x is still up there. Okay, but the x is in the exponent. It's not, like in the other two, linear or quadratic, it's not written down there on the bottom and has an exponent of a 1 or a 2. The x is the exponent. Okay? Your graph description is that it's going to get large quickly or get smaller quickly. One or the other. Okay? Because there's two different types. You could have what we call exponential growth or exponential decay. It's one or the other. You can't have both at the same time. So if it's growth, it's going to get large quickly. If it's decay, it's going to get small quickly, which again is something you'll learn in Algebra 2. But you need to know what the graphs look like. Okay, this is a growth graph. Notice that it kind of makes like a J shape, but it starts out small over here and gets large really quickly. And it's going to keep getting large until we stop at some point. Okay? That's an exponential growth graph. For decay, it's just the opposite. It makes kind of an L shape, curved L, but it starts really large and then it gets really small. Those are exponential graphs. Now for our chart here, we're going to fill it in. Remember again that the x is the exponent. So we're going to put these in our calculator. We're going to do 2 to the negative 1 power. When we put that in our calculator, we get 0.5. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power, which is really 2 times 2 times 2, is 8. Don't do 2 times 3, because that's not the same thing. 2 times 2 times 2, 3 separate times will give you 8. And the pattern that we're looking for here is that you multiply by the same number each time. Okay? For linear, we added the same number each time. For an exponential, we multiply by the same number each time. And over here, we're multiplying by 2. To get from 1 to 2, we multiply by 2. 2 times 2 is 4. 4 times 2 is 8. The next number would be 8 times 2 is 16. So if I plugged 4 in there, 2 to the 4th power should be 16, and it is. It works. So that's one way to tell if it's an exponential looking at a chart. Now, I expect you to be familiar with all of this. I know it's a lot of information to take in, and some of it you should already know. Slope-intercept form you already know. You know how to graph lines, all of that stuff. So the linear column should be good. Quadratics and exponential may be new to you, but I do expect you to know it. Those are your notes for section 6.6 on types of functions, and we'll expand more on that in class next time. So make sure that you understand and bring any questions you have to class next time. And those are your notes for section 6.6.